Mechanism and Stereochemistry of 1-methyl-cyclohexene chlorination by Malik Abdurrahman. So this is a full curly arrow mechanism for the formation of one chlorinated product, drawn by me. Okay, so step 1, the electrophile attack on Cl2. The pi bond of 1-methyl-cyclohexane acts as an electron source. It attacks a chlorine atom in ClCl, causing the bond to break. This produces a chloride ion and a chlorinium ion intermediate. Step 2, the formation of chlorinium ion. The chlorine atom forms a 3-membered bridge ring with the alkene carbons. This chlorinium atom blocks one face of the molecule, preventing attack from that side. This step explains why anti-addition occurs later. Step 3 is the backside attack by chloride ion. The chloride ion acts as a nucleophile, attacking the opposite carbon. Attack must occur from the backside because the chlorinium ion ring blocks the front. The nucleophilic attack opens the ring, forming the product by anti-addition. So step 4, the formation of the trans-dichloro product. Because of the attack is from the opposite side, the two chlorine atoms add two opposite faces of the ring. This gives trans-1,2-dichloro-1-methyl-cyclohexane, which is the product I drew. And then the reference is down below. And then this is also drawn by me. This is the final step of the mechanism, identifying nucleophile, electrophile, electron source, and electron sink. So the nucleophile, the chloride ion carries a lone pair shown in blue. This lone pair acts as an electron source in the reaction. Cl- attacks the electron deficient carbon from the backside. Electrophile is the carbon attacked to Cl positive. The carbon in the chlorinium ion is delta positive because chlorine withdraws electron density. This makes that carbon the electrophile. The nucleophile always attacks the carbon, not the chlorine atom. That's the difference then between them. So electron sink is the CCl bond in the chlorinium ion. The CCl bond, shown in the red, is the electron sink when Cl negative attacks. This bond breaks, and then the electrons move onto the chlorine atom, opening the ring. And then the backside attack and product formation. Because the chlorine bridge blocks the front face, Cl- must attack from the opposite side. This leads to the anti-addition, forming the trans-1,2-dichloro-1-methyl-cyclohexane, product shown on the right, which is obviously over here. And then, and then why only 2 trans products form in the chlorination of 1-methyl-cyclohexane? Only 2 of the 4 possible dichloro products are formed because the reaction proceeds via an anti-addition mechanism. When chlorine reacts with 1-methyl-cyclohexene, a chlorinium ion intermediate is produced. This 3-membered chlorine bridge blocks one face of the molecule, preventing chloride from attacking from that side. As a result, the chloride ion can only attack from the opposite face, which is the backside attack, causing the 2 chlorine atoms to add to opposite sides of the ring. This produces only the 2 trans-dichloro stereoisomers, while the cis products cannot form. So this is the chlorinium ion blocking one face. As you can see, this image obviously describes that it's only coming from blocking one face. This is the backside attack by chlorine ion. And then this one is the anti-addition, trans product only. And then the absence of cis product formation. And then this is the alternative products formed in ethanol, nucleophilic substitution of the chlorinium ion. This is drawn by me. And then the outcome of heating 1-methyl-cyclohexane with ethanol under reflux. So when 1-methyl-cyclohexane is heated under reflux with ethanol in the absence of any other species, no halogen is available to form a chlorinium ion. Instead, ethanol behaves as a nucleophile or nucleoprotic solvent and adds directly across the alkene double bond. This results in electrophilic addition, where the alkene is protonated first, forming a carbocation on the more substituted carbon, which is the Markovnikov addition. Ethanol then attacks this carbocation to produce 1-ethoxy-1-methyl-cyclohexane as the major product. This is the electrophilic addition of HCl to 2-butene, mechanism and product formation. And then explaining the double chlorine addition. So both chlorine atoms attack to the same carbon because of Markovnikov's rule and the stability of the carbocation formed during the second addition of HCl. After the first equivalence of HCl adds, a vinyl chloride 2-chloro-2-butene is formed. When the second HCl molecule adds, the proton H+ attaches to the carbon that does not have that the chlorine, leaving the positive charge on the carbon that already carries the chlorine atom. This carbocation is more stable because the chlorine already bonded to that carbon can donate electron density through the inductive resonance effects, helping to stabilize the positive charge. The chloride ion, Cl-, then attacks this more stable carbocation, so both chlorine atoms end up on the same carbon, giving 2,2-dichlorobutane.